Okay, so here we have, I'll just shrink this a little bit so we can see the whole thing. Okay, here we go. So reciprocal function. So what I've drawn on this screen already is, sorry, it's a little bit shrunk there, is the parent function for a reciprocal function. So it's 1 on x. And if you remember, oh, it's too dark, sorry. If you remember, a reciprocal function has the following properties. I'm just going to zoom up so we can see that because there's nothing else to see at the moment anyway. So we have, as x approaches a very large number, so we say, as x approaches infinity, we can see that 1 on x will approach 0. So we have the graph nearing that way or nearing that way. Okay, it's approaching 0, but it never reaches 0. As x gets really small, so in other words, as I take the value of x towards the y-axis here, we can see we're going to have 1 over a small number, and we should sort of understand that 1 over a small number is going to give me a big number, like 1 over a half is 2, 1 over a third is 3, 1 over 1/1,000,000th is a million, and so on. So as x gets close to 0, f of x gets close to infinity. So we have near it and near it there, okay? So with the negative just affecting whether it's getting very big negatively or very small negatively. Good so far? That's the reciprocal function in a nutshell. So as a result of the way it's zooming, we end up having a vertical asymptote, yep, and a horizontal asymptote. Yep, asymptote. I think it might be asymptote. We have two values that the graph never reaches but does go towards, okay, which is what the definition of an asymptote is, okay? So I don't know if it's really clear there, but I've just sort of dashed it out in red there. In this case, it's the axis. But what we're really talking about, the axes, I should say, but what we're really talking about is what values does the graph reach without actually hitting. So I'll just leave it zoomed out now and I hope it's going to be okay. So the example I left on the board was this, and we're going to just look at it together, but maybe not with a red pen. There we go. I'm sorry if I'm keeping you awake. You're either tired or bored or both. Fair enough. F of x equals 3 on x minus 2 plus 1. Now, some of you probably think, well, that's a bit unfair. That's much more complicated than you've given me previously. But you know what? It's not. Let me give you an example, which because of your familiarity, you'll probably go, actually, that looks, I could graph that easily. If I asked you to graph, don't write this down, please. If I asked you to graph f of x equals x squared, I reckon most of you would sort of, maybe not as wobbly as me, but you'd probably draw it a bit like that. Cool. And if I said, okay, but what if I gave you f of x equals 3 outside of x minus 2 all squared plus 1, I bet you could graph it because we've just done a quadratics unit. And I bet you wouldn't look at that and go, that is massively complicated. I can't do that. Because you know that the 3 affects the dilation. You know that the minus 2 affects the horizontal translation, i.e. this way. And you know the plus 1 affects the vertical translation. And so without any particular accuracy, you know that it would be something like something like that. I haven't done the dilation there really, but by putting in some points, you'd see the dilation in effect. Is that okay? So, so it's just, what I'm trying to tell you is don't be frightened by more complex looking stuff if you can identify the parent graph. If you can see that the parent graph is 1 on x, I'm just going to fix that, fix the view there because it just looks a bit dodgy. Yeah, I have full screened it, but it still looks a bit dodgy. It's just not, the resolution's a bit dodgy. Oh well, we can't do anything about it. So we're going to apply the same sorts of principles to this graph here, right? The main thing really is to get where the asymptotes are. And the asymptotes, remember, are the values which the graph approaches. So when I look at, let me just do one at a time. The +1 will affect, what do you reckon it will affect? The vertical asymptote or the horizontal asymptote? You think so, right? But it doesn't. Because what you're going to do, it's going to be really hard for me just to show you on this. What it's going to do is, you know that it's going to be a vertical shift, right? So everything shifts up. So this shifts, this will shift. This vertical asymptote, just with the +1, does nothing. It just shifts up. But this is like an infinite line, right? So it just shifts up and you can't tell. But the horizontal asymptote will also shift up by 1. So in fact, the +1 affects the horizontal asymptote. It becomes the horizontal asymptote. To put it another way, as x gets really, really big, the -2 is a bit negligent. Not negligent. Negligible. Negligent means, it's not taking care of itself or others. Negligible means insignificant. So the -2 is like, if I made x a billion -2 is 999,998,998. So it's negligible, right? So in other words, this one just still disappears to 0, effectively, and so you're left with 1. Okay, so the new asymptote is, let's draw it nice and straight, as if I was using a ruler. Okay, so we've got our x axis, we've got our y axis, and the new asymptote is really going to be like this, right? It's effectively shifted up by 1. Does that make sense? Of course I haven't finished, I'm just saying. Because effectively, when x approaches infinity, when x gets really big, either positive infinity or negative infinity, this bit, Ambrosia, have a look on the screen so you can see what I'm circling. This bit will go to 0, but this will remain constant, right? This will be still +1. So although this goes down to 0, this +1 means that the whole function is approaching 1 on either side. Now, what about the vertical asymptote? That changes as well. And it probably won't be any shock to you, really, if you think about your quadratic function work, that if I've got an x minus 2 down the bottom, then it's going to shift it which way? Yes, to the right. So it's going to go to the right 2 units, yeah? So just trying to make it to scale. That looks a bit okay, doesn't it? No. No, yes, you could if you wanted to. You could say, but really, H and it doesn't. There's no real. I don't think there is any particular value, but you can use H and K if you want to. Now, yeah, I know why you said H and K, so it's okay to use those. What I'm saying is, although H and K is very specifically almost always used for quadratics, I don't know if that's the case with a reciprocal function, but I really don't really know. I can't really remember. Okay, but so is that okay? So if you then just put in the curves now, like that, and like this, you'd be okay. But really, although this one is dead cert fine, because it's sort of like, just what it is, this one's not fine. Because is it like that? Or is it like that? Where's that y-intercept? Where's that x-intercept? We don't know. So guess what? We have to calculate them. Sorry? Is it? I doubt it, because that would make the y-intercept up here somewhere. Just for the video, answer last is the y-intercept 5, and I'm just saying it probably isn't, because that would put the y-intercept there, but we know that it's got to be in here somewhere. So we've got to calculate it. That's all. Just got to calculate it, but that's no drama, because again, you know how to do that as well. It's the same idea over and over again with our different graph types. For a y-intercept, we say let x equal 0. For an x-intercept, we let y equal to 0, and we solve. It's as easy as that, and as hard as that. Okay, so y-intercept, let x equal 0. So f of x is equal to 3 on 0 minus 2 plus 1. So that's equal to negative 3 on 2 plus 1, which is equal to negative a half. So 0, negative a half. I'll stop there for a moment. You okay with that? It's substitute and solve. Again, if that's looking like voodoo magic to you, then you'd have to ask yourself, where am I getting lost? Is it that I don't understand why we're setting x equal to 0? Or is it because I don't understand the substitution step? Is it because I don't understand my fractions yet? Every single one of those statements can be solved by review, by asking me to help you, and all that kind of stuff. What won't help is if you just let it wash over you without being critically thinking about it. X-intercept, we know there's only going to be one, but the process will tell us anyway. So always, 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 we keep on thinking, what do I need to find out? What do I expect? What do I expect? And if the answer is, look, I think there's only going to be one x-intercept, I'm pretty sure there will be, then you won't be surprised by the results. Okay. So let y equals 0. So we've got 0 equals 3 over x minus 2 plus 1. Jeremy. They now cross the axes. Can you see the right-hand side, Jeremy? This area here, it's right there. It's almost definitely gonna. Well, I won't even say almost definitely. It's definitely going to cut through somewhere because of the shift in the asymptotes. Okay, so I love the clarification questions, though. They're always really useful to get those things. So thank you. So that's minus 1 is equal to 3 outside of x minus 2. This is all algebraic manipulation. So again, your fundamental skills are the building blocks from which you can build a beautiful house. So if your algebraic skills are a little bit weak, work on them so you can be a master crafts person at this kind of stuff. Am I stretching that analogy too far? Yes, Richard. Yes, I am. Negative 1 multiplied by x minus 2 is equal to 3. I multiplied both sides by x minus 2 there. I'll just go and write that in because it's otherwise looking a bit opaque what I'm doing. Okay, so multiplying by x minus 2 on both sides. The aim of the game is to work out what x is, so I'm going to have to expand that. So I've got negative x plus 2 is equal to 3. I'm going to subtract 2 from both sides to get x, negative x is equal to 1, and therefore x equals negative 1. So I've got negative 1, 0. Okay, so now I can return to my graph and I can see that I'm not even going to put them in. I'm just going to sense where they need to go. Remember how we sort of said that sometimes if you put the intercepts in first, then it's really hard to get your graph hitting those points. So I'm just going to aim for a little bit of understanding of scale there. So I've got minus a half for the y-intercepts. That's about there. And I've got minus 1, which would be about there. Okay, so it's going to be, okay, this is going to scare me a bit, but doesn't matter too much. But so the main thing is I know that it's going to cut through here and then keep on heading towards that asymptote there. And as long as I label it, even though I've been a bit dodgy with my scale there, I'm okay. And again, the dilation of 3 means that I would expect that to be stretched, and it is pretty much from the asymptotes in this case, really. And that's the graph done. Okay. So what I'm going to do is just give you a chance to do a little bit of practice from the textbook, not long before I move on to the more complicated kind of functions. Yeah, it's effectively A, Archie, if you want to put a letter to it. No, all good questions. Not every single question is a good one. Like, I'm tired today, do we have to? It's not a good question. But everything I've heard today has been a good question. Okay, what I thought I might do is just try and introduce a little bit of graphics display calculator work as we go along, because I'm just conscious that in the quadratic functions test that you've just undertaken, perhaps your manipulation of your graphics display calculators needs to be, in some cases, polished, in other cases, started. So what I'm going to do is I'm just going to do a little bit of work on it each lesson just to try and build up your skill set a bit. So could you please get your graphics display calculators out? And we're going to graph this on our graphics display calculator. Sure, if you're really quick. That's everyone, is it? Not everyone, I beg your pardon. That's quite a few of you, though. And Archie as well. And Jeremy. Well, that's fun. Okay, sneak peek then. I won't do the graphics display calculator work until they return, but there's the graph that we drew. And here is what it looks like in Desmos. So that's pretty reasonable, isn't it, what we drew? And just to sort of show you, if I just put in y equals 1 and, let's change it to f of x so it looks properly. And if I put x equals -2, oops, 2. There we go. So you can see here in Desmos, that's the actual graph there. And what you'll find is that the dilation factor effectively kind of, it stretches the graph away from the asymptotes effectively, because they're sort of, the 3 sort of triples every single value, right? And so it's not pulling in as closely as it would have otherwise. So that's the effect of it. The other thing, what was the other thing I wanted to say? Oh yeah, the other thing I wanted to say is, based upon the sketch that we did, one thing which I didn't make you do, but one thing that might help a little bit with scale would be to pick a point somewhere in here and label it. So I won't do this, but just for example, I can see that I could choose 3 or 4 on this side of the asymptote, substitute it into the function and work out the y value, and then I just label that point. And again, by labeling a point, it just gives that sense of scale. I have 2 points on the left-hand side already, so I have that point and that point, so I don't really need anything for that side. But if I wanted to be super duper clear with my mathematics, I'd probably choose just another point over here to give a sense of scale on this side as well. Not super duper critical, but it would really help. Okay, am I waiting on anyone? What am I waiting on? Zoe. She's got caught in a conversation, maybe. Right, I'm going to move on. She can always review the video later if she needs to. So, graphics display calculator. If you've got it on, it'll look a little bit like this. And what we're going to do is we're just going to get into graph mode. So you can either just click on graph down here because we're just doing scratchy kind of graphs, but you can, if you want to, go to new document. Now, one thing I think will help you with your graphics display calculator is I think you need to be keyboard warriors. And that means just get used to using the numbers and letters that are next to some of those commands there, because if you get proficient at it, it's a lot faster than moving that little scrolly mouse around. Okay, because the trackpad's not that great. So I can see one for new document here. So I'm just going to create a new document. You right, Jeremy? Okay. And then the good thing about a document is that you can create multiple sorts of pages which interact with each other. But we won't be doing anything that complex for a while. So you can see there under all these ads, there's add graph. So that's all I'm going to do. So I'm going to press 2, and that adds a graph. And then we're going to type in the graph, right? So it was 3, and to do a fraction, you just use the divided by button. So if I go over here and go divided by, and then put in a bracket, x minus, what was it? Minus 2, wasn't it? So use x minus 2. Yep. So 3 divided by x minus 2 is the fraction part. Yep. And then go plus 1. No, not the whole thing. Yeah, why? Yeah, exactly right. That should be all you need to do. I don't know why mine didn't turn into a fraction. It normally does. No. Anyway, it should graph it anyway. So 3 over x minus 2 plus 1, and then press return, and you should get the graph. Sorry, Archie. Random what? That's just where the text box is. So if I move that text box, you can just grab it. No. So what we're going to do now is we're going to we can. I don't know if it will calculate. Let me just give me a second because I haven't tried putting asymptotes in before. Just give me a second. No, it doesn't put them in. I thought there might have been a way of calculating it. So you'll still need to know enough. Wow, that was annoying. Who was singing? You still need to know enough in order to be able to do the next part, I suppose. So if you want to put the asymptotes in, which you don't have to, just trying to get out of this now. Hey, can I have people not talking over me, please? Every time you see me go and then repeat what I have to say, it's normally because I'm processing conversations in the back of my head. At the back of my head, I should say. I'm not saying I've got split personality disorder. Okay, so just keep it to yourself, please. Okay, so we've got a graph of f of x equals 3 outside of x. Now, you don't have to put in the asymptotes, but if you want to, you can. If I go Control G on my keyboard, you can just press Control and then press G. You don't need to hold them down at the same time. You'll notice it now says F2 of x. Control G. Control then G. So that means new graph, right? So if I go, this is y equals, what was it? 2. So if I go f of 2 equals 2 and press return, oh, darn, I got around the wrong way. Sorry. No, it means I went around the wrong way. If I go f of 2 equals 1, then I've got my horizontal asymptote in. And then if I add this, I can't remember how to do, hang on. Now, to do the horizontal the vertical asymptote, I'm going to have to enter a relation instead. It'll only allow me to enter functions. Now, remember, functions had that vertical line test, right? So I can't put in a vertical line because it's a relation, it's not a function. So if you create a new graph, so it says f3 of x, and then hit menu. Oh, it's not menu. Sorry, my bad. If you press control menu, it'll say graph entry edit. If you then press 1 for graph entry edit and then 2 for relation, it'll say rel1 x comma y. That's what you want. And then go x equals 2. So I'll say that again because I was working it out as I went along as well. When you add a new function, so f3 of x, you then go control menu, which is effectively a right click. It's the equivalent of a right click. And then when you go control menu, you press 1 for edit the kind of graph it's going to be, and then choose relation. Type x equals 2, and it should give you the horizontal asymptote, vertical asymptote. Just come around and check.
I lost it at the vertical bit.
Yeah, so add a new graph, control G. Then, so it should say F3 of X or something. Yeah. Okay, now go control and then menu, which is like a right click. Press 1 for graph entry edit. And then press 2 for relation. Try and get used to using the keyboard. Yeah. And then type X equals 2.
Control menu.
I don't have a charger. I went up to the maths office and no one was in the maths office.
Right. Okay, I didn't bring my spare one, so just have to watch on. Where's yours, Sophie?
Control menu is not doing it.
It's no good there.
I click control menu.
No, you need to add a new graph first, so control G.
Oh, control, where's G? Literally just one of these.
Literally the letter G.
Okay. Alright.
Okay, so you haven't done the horizontal asymptote either. So,
no,
f of x equals 1 is the horizontal asymptote.
Yep.
Okay, and then control G. And now this is a function we need to turn into a relation. So you're going to go control menu. Then you're going to go down. You'll go to, that one. So number 1. And then number 2. Try and get used to using the keyboard.
Yep.
And now you're going to type in x equals 2. Now, I have to say, the reason why I force you to do that is just really as an exercise in getting to know your graphics display calculator. Personally, if I were graphing this value, if I were graphing this function, there's no way I'd bother putting in the asymptotes. I'd know them, but I don't care about seeing it on the screen. I just don't care. But I just made you do it so that you can see how to add more functions and stuff. Ambrosia.
Mine's flashing.
No, it's probably because it's selected or something. Okay, so next thing. What we're going to do, this is probably a pretty important skill, is we are going to learn to work out some critical values from this graph. So pretty much use the same sort of thing for quadratics and stuff as well. So if I go to the menu and I press, again, please try and get used to using your keyboard rather than the trackpad. So 6 for analyze graph. And you see that you've got some options here to see some stuff. You can analyze the zeros. You can work out the minimum or maximum, which may or may not be a turning point, an intersection, all those kinds of things you can work out from this graph. Now, it doesn't allow us to work out the y-intercept, but we can sort of do that in a different way. So just a reminder that zeros simply mean the x-intercepts. So if I press 1 for zeros, it says, which graph do you want to work out the 0 for? So you then need to go and select graph F1 with your cursor. Please don't go any further than that. So a single select, you'll know you've done the right thing because then the question will be lower bound question mark. Raise your hand if you're not ready to continue. Menu button. Yep, and then select the graph. You could probably select the graph first and then go menu, I suspect. Now, the lower bound, what it does is it will analyze the graph for a selection of the domain that you set. Okay, so if you could imagine if I was doing a cubic with 3 intercepts, I may only need to find out the left-hand side one, so I'd only have to select a part of the graph. So effectively here, what we do is we use our cursor keys to move this vertical line just before, it doesn't matter how far before, but just before the x-intercept, and click. Then it will ask for an upper bound. So then use your cursor keys to move the other side. Doesn't matter how far you go as long as you've got past the 0, and click again. And there you can see the values given to you, -1, 0. And again, you can select that bit of text and you can move it out of the way if you want to. How do I get the highlight bit? Where I highlighted the region, that bit. So, I'll see if I can delete it. Okay, so again, I go menu, analyze graph, 0. It asks me to select the graph. It's telling me, can you please select the graph? So I select the blue line. I then says choose a lower bound. So this is the left-hand side of the 0. Single click. Upper bound, drag to the right until it's the other side of the 0. Single click, and then the 0 is defined here for you. Tara, yes? Cool. Everyone else, yes? Okay. To work out the y-intercept, this might be a smart way of doing it, but sorry, I think I'm by myself. I think I'm talking to myself. I'm just worried that you're not going to be able to see the next part. To work out the y-intercept, probably the best way to do it would be to go to number 5 this time, which is a trace, and then just go graph trace. So it's menu 5, 1. Because we already had the graph selected, it's automatically just put a little cursor line on the graph here. And you can then use your cursor keys to sort of move along the graph. You can identify zeros that way as well, but I'm just going to move it to 0, -0.5, and you can see that it's given to me here. So do you want me to go through those instructions again? Last time, because I'm getting really sick of this chatter behind me, I'm just sick of it. So I'm going to assume the graph is not selected this time. So menu, this time we're going to go to 5. This time we're going to go to 1. So menu 5, 1 for a graph trace. It looks like it's automatically selected the blue graph here, so I'm okay. Then I can use my arrow keys on my trackpad to move through the graph. It will get you zeros this way as well, but it'll also allow me to work out the y-intercept. And you can see down the bottom here that it says 0, -0.5, so -0.5. Okay, so in summary, Control G allows you to add a graph or a relation. The menu, by selecting menu, you can perform a number of operations. Importantly, you can analyze the graph for specific information. You can trace the graph for specific coordinates. Any questions? Okay, so what I would like you to practice, please, is I'd like you to practice confirming your answers using the graphics display calculator so that when you get to a test, you can be really proficient with using this calculator rather than trying to hunt around for options that you only half remember. Okay, it is now 9:18. I'd like you, please, to go to your textbook and you are turning to page 149. Again, I'm concerned that people are in their own little world rather than paying attention to what the teacher is trying to instruct them to do. And I know that these same people will then turn to me and say, wait, what did you say? Can you repeat your instruction, please? And is that fair? Except that I asked you to confirm your answers on the calculator during this session. Okay, exercise 5C. I want you to do every second problem. Oh, G, H, and I are a bit harder, but do every second problem in question 2. Yep, that should be enough. And again, confirm your answers using your graphics display calculator, but see if you can sketch it by analytically, which means just using paper and pen. And then if you've got time, do questions 3 and 4. And we will move on to the more sophisticated kinds of functions called rational functions next lesson. Does anyone have any questions? So right now you are practicing sketching graphs, confirming with your graphics display calculator, and then in question 3 and 4, you're seeing whether you can interpret a context, an application question. Oh my gosh. Question 2, every second problem, then questions 3 and 4 if you've got time. Yep.